Hello and welcome to my chemistry in captivity video. In this experiment, I will be focused on detecting and measuring calcium dissolution in seawater across different environments. I collect from two main conditions, hot water and cold water. In hot water, there will be warm calm, warm intermediate, and warm active. Warm active will have a bunch of bubbles, and warm intermediate, not so many bubbles, but bubbles. Then for calm, it's going to be the same three categories with the same bubbles. And then for both of those, they will have a control each. At the top left, you'll see the bubblers that I'll be using. They're adjustable. For the active, it's set to the maximum, and for intermediate, it's set to the minimum. I will be also using a vacuum flask filter thingy, as it will just help with the calcite. Anyways, so what's the chemistry involved? These are all the equations. The main thing will be dissolution of calcite, but also, really importantly, later on, the absorption of water with calcite. So at the top right, we have the hydrate of calcium carbonate, and then at the top left, we have calcium carbonate turning into its two ionic form, or its two ions, splitting up. So here's the three. Warm intermediate, warm calm, and warm active. So beautiful. Look at all that calcium. Here's all the data. Main thing to take away is it's increasing, except warm intermediate, as I messed up and did an error and we lost some calcium. But I will go into further detail at the end of the video. Here are all the temperatures. Not too important, but it's a good idea to see what they were like. With a hot water bath, I will definitely say it's hard to keep a consistent temperature. Now let's move to cold intermediate, or no, I mean just cold in general. We got cold calm, got cold intermediate, and got cold active. Here is their data plots. For this one, it is also all increasing, and nothing decreasing as I didn't mess up. Yay! This is the temperatures for them. As I was using a mini fridge, it was definitely a more confined area, so the temperature was definitely consistent. That was very nice. Here are our two controls. Beautiful calcite, as always. They were both also increasing. Number one kind of like stabled out for like first week, but I do believe that might have been error to me as well. Took a while for the scale to balance out. I will definitely say that. But yeah. So results. Warm water. We had a change of weight for warm calm of 0.07 grams. For warm intermediate, technically it is negative 0.01 grams. But as I mentioned before, I messed up with the calcite and we lost some mass. So I'm going to go off week 2 for all my calculations, and that was a 0.02 gram increase. It was the same for warm active, and for number 1 control, it is 0.03. For cold water, we have a 0.12 gram increase for cold calm. Cold intermediate, a 0.23 grams, the most added weight. And then for cold active, we have 0.13 grams. And then finally, for number 2 control, we have 0.05 grams. Also, I'd like to apologize. I know that there's not an E at the L. I don't know why those two have those there. So, what can we interpret it from these results? Increase of weight for the calcite for both temperatures. Specifically, though, cold water gained more weight. Agitation influence, inconsistent. Didn't really see anything because the warm active gained less than the warm cold, while the cold active gained, or calm. Warm calm, sorry, while the cold active gained more than the cold calm. Dissolution of calcite hidden by H2O absorption, probably, possibly. Um, no mass loss in the calcite except in warm intermediate, again due to error. So let's move into the chemistry. This is all the the equations I'm going to use that helped. So first we found the theoretical water mass gain. Um, we take that by dividing the molar mass of water by the molar mass of calcium carbonate monohydrate, I believe it's called. And we get 15.25% or 0.1525%. You take the minimum, like starting out weight, times that by the 0.1525, and then you get the theoretical water mass of the calcium. Next, we find the observed mass gain. Pretty simple. It's just mass change, so final mass minus initial mass. It was everything I stated before. Again, for warm intermediate, I'm using week 2, so to get that 0.02 grams, that negative just threw off all the calculations for warm intermediate. Okay, and now we'll move on to actual percentage of water absorbed. So as we know, the maximum H2O percentage can be 15.25. So to find the actual percentage of H2O, you take that number or that percentage, times it by the mass gain divided by the theoretical mass gain for calcium monohydrate. So we do all that, get all the nice percentages of how much water is of the calcite. Then we move to the next part, which is finding the true mass of calcite. Since now we know how much water is in there, we can subtract that to get the actual mass. And, well, we got all the same numbers as week 1. A little disappointing, but also kind of cool. I was able to remove the water and see that it didn't really change, at least not detectable on my scale. So, yeah, speaking with about interpretations and stuff, how much calcite was dissolved? None. But this is how much H2O was absorbed. If you've seen these numbers before, it's the same one as the mass gained, the change of mass. Again, little weird thing with the warm intermediate, but it's cool seeing how much water was absorbed. It's definitely not what I expected for the experiment. I did believe that there was going to be some dissolution, or at least some that would be able to be readable on my scale. There probably was dissolution into the surrounding water, but it could have just been undetectable for me, as my scale wasn't too specific. It wasn't a scientific one. Now let's move on to errors. As Hannah Montana once said, everybody makes mistakes. So error 1, the one that I've been talking about, loss of calcite during the warm intermediate transfer. As I pour it into the vacuum filter, and then I have to scrape that calcium out and dry it. So calcium was lost. I jerked my hand, and a little bit went flying. So there was definitely some calcium lost evident in the data. There was probably also that for all of them, objectively. Clearly not enough to skew with the rest of the results. For error number 2, power went out during a day for the cold week. It didn't really throw it off too much, but it got really humid in the fridge, so I don't know if that would affect anything. I just think it would be important to note. Error 3, last measurement of all the warm waters was rushed. Unfortunately, I did have to rush it, so the scale wasn't allowed to fully settle, so it might have been a little skewed off that. So next time I would just make sure to give myself a bunch of extra time. I think it would also be really important to allow calcium to dry overnight. I did not really allow myself that time. I think that would have helped with the water stuff. But yeah, that's it. I hope you enjoyed it. This experiment took 2 months. I worked hard. I'm pretty. I didn't get the results I was hoping, but I still think it was pretty cool seeing how much water was absorbed. Um, I know I was expecting calcium to at least uh, dissolve more in cold water, as I know calcium dissolves faster in cold water. But yeah, hope you enjoyed. Thank you.